Yes, thank you very much. Good morning, good afternoon to everyone, and thank you for joining today's webinar. My name is Jasper Verburg, and within Damco, I'm responsible for our efforts in the field of service innovation. So it's my role to observe and interpret the supply chain industry and customer trends, and to facilitate the selection and the execution of projects that lead to new services for existing and new customers. So in essence, what I do is I contribute to Damco rendering services that are regarded as industry leading and making customers to prefer Damco over others. However, today I don't intend to talk about the Damco services. Instead, I would like to share with you some of the things that we have come across in working with our customers in their attempts to deal with increased dynamics in their business environments. In particular, I would like to show you how vendor compliance and automated load planning can help companies to improve their supply chain performance in today's much more dynamic environments. So some of you might be experts in this field already, whereas others might be relatively new. So I can well imagine that for some I might walk through too fast and at too high level, whereas for others I might take too much time and look too much into details. It's a little bit difficult to accommodate everybody in such a webinar. But in any case, as we only have scheduled about 30 minutes for this presentation, I'd like you to sit back, relax, and reflect which elements of what you hear today are relevant to your business. Should you have any questions, please do post them via the chat console, and I'll try to answer them during the Q&A part following the presentation. So here's what we'll talk about today. First, for those of you who are not familiar with Damco, I'd like to just spend 2 minutes to briefly introduce you to our company. And next we'll then dive into the core of today. So first, to help understand the relevance of a dynamic supply chain, we'd like to indicate some frequently observed market challenges that contribute to today's markets. Those markets being less stable than before, and thus also indicate the need for supply chains to be much more flexible and agile. We'll then see 2 examples of customers who have successfully used a vendor compliance program to limit the upstream variability in their supply chains. As a result, they have been able to reduce origin lead time and set the conditions for successful automated load planning. And finally, we'll look into how automated load planning may be used in execution at origin management. So we'll cover some of the basic functionality and the typical logic that is applied in a complex, large volume operational environment. We'll also explore some of the advantages of using decision tree logic, and in particular the ease of applying supply chain segmentation. And we'll see why only using decision tree logic may actually not be sufficient to reach optimum results. And finally, we'll see an example of the benefits of one of our customers who enjoys using the automated load planning. And of course, then, as said, we'll close off today's webinar with a short Q&A session for which you may submit your questions during the presentation via the chat console. So let's have a quick look on who is Damco. So Damco is part of the global Maersk Group. And as probably all of you know, we're a large shipping and energy company. We're headquartered in Denmark with revenues just over $47 billion and close to 90,000 employees. The business has been split in 5 business units. We have the Maersk Line business, which is typically the container line. We have Maersk Oil and Maersk Drilling, who focus on the exploration and production of oil worldwide. We got APM Terminals, predominantly looking after the loading and unloading of vessels coming into ports. And then we have the business unit Services and Other Shipping. And Damco sits within that business unit, together with 3 sister companies. It's Svitzer, they're looking after the towage operations. It's Maersk Tankers, and it's Maersk Supply Services. And the latter looking mainly after the supplier vessels for the offshore industry. So specific to Damco, what do? We are today one of the leading freight forwarding companies, and we serve, just over 10,000 customers. And what is interesting is that the top 25 customers have been with us for more than 10 years. So it signifies the value that we put on long-term relationship there. We operate our own office network to make sure that we're close to where you are. And we're present in over 100 countries with approximately 11,000 employees. Last year, turnover was about $3.2 billion, And the activities that we earn our money with is in ocean freight, where we manage about 2.8 million TEU on an annual basis, and in supply chain management services. And supply chain management services for us is mainly the services at origin, making sure that the goods departing from origin are actually arriving on time at the ports where they need to depart, be it either in ocean or in air freight, because on top we also do operate our own air freight products, and we have last year moved around 225,000 tons across the globe. The Damco headquarters is in the Netherlands, where I'm presenting from today. In terms of customers, we do serve a wide range of customers from what we have called verticals. So the majority of our customers are from retail and lifestyle, but we see an increasing number of customers coming from technology, industrial, chemicals, mining, aid and relief, and the government and defense industry. What we'll see today is predominantly coming from our activities that we do for retail and lifestyle and the experiences that we see there. So we'll just like to share with you some of the experience there and see how it may render benefits to your business. So that's all regarding Damco, as said, in a nutshell. So let us now dive into the core of today's webinar. And let's first explore which circumstances typically drive the need for a much more flexible and agile supply chain. So in today's world, markets and supply chains have become global. Flexibility and agility are key to be successful, as demand shows more difficult to predict and supply delays and disruptions are frequently observed. And some of these typical characteristics of a global business environment includes, amongst other things, the things that you mentioned here on this slide. So in terms of increasing customer requirements, what we see is that ultimately consumers are in the driving seat, and consumer behavior actually spreads across industries. Customers more often require deliveries to be faster, cheaper, and more frequent. And they also require products to meet their exact needs and deliveries to take place where they want it and when they want it. Amongst others, this results in a need for a much more of a diverse delivery network, and we see a reduction in the average shipment sizes. And it also enhances the difficulty in accurate S&OP planning and forecasting. We also see increasing complexity, and not only have markets become more global, often supply bases have also become more global. The emergence of lengthened and dispersed supply chain networks has increased the complexity in supply chain management. Moreover, companies often rely on multiple interdependent partners to successfully execute their supply chains, making the networks more vulnerable to any disruptions. And near sourcing not only provides benefits to companies, it would typically also introduce additional shipping options from factories to demand regions, making the shipment planning and the execution even more critical. And furthermore, the emerging markets add new destinations for a broader, more geographically dispersed customer base. And of course, particularly relevant to the retail and consumer markets, the necessity of a seamless omni-channel experience requires timely and smart decisions on which products to be allocated to which channels. We see an increase in competition. So globalization not only brought opportunities to companies, it has also introduced new competition. Companies who recently were suppliers in low-cost areas, they're now becoming powerful competitors. Operating smart and efficiently is something that they do, and therefore it's also critical to your own business. Disregarding efforts to take down trade barriers, the global nature of today's supply chains do require a regulatory framework to provide an equal playing field to all. And companies need to operate efficiently within those restrictions. These restrictions, combined with any in-house developed company rules, limit the degrees of freedom to plan and execute supply chains. So whilst companies are well aware of the dynamics and complexity of the environments they operate in, they all frequently have to deal with the similar challenges, and a few of those challenges are listed here. Adapting and efficiently changing circumstances, that's a critical thing. Yet with little resilience built into the supply chain, some companies have difficulty to counterbalancing the increased risk profile of a complex supply chain network. The accurate and fast decision making obviously is important. And to draw the right conclusions, it's important to take into account the bigger picture. and also the effects of decision making beyond the issue that is just on hand. Yet in many companies that we see, decision making is fragmented either by 3PL, by department, by region, so it basically leads to suboptimal results. And although initial order and shipping planning often is done in an automatic fashion, fine-tuning and final decisions may rely on a manual intervention with a risk of reducing accuracy and adding the planning time and staff costs. Not all companies have the ability to efficiently change purchase orders, even when it would have been better to do so. In fact, we often see it doesn't happen. In such situations, orders remain unchanged and a push-based shipping behavior is encouraged. Moreover, whilst many believe that anticipating on scenarios and available options add value, companies may still be organized to react to change rather than to preempt change. And even when proactiveness and risk mitigations are actively pursued, exception management will likely still be required. So companies may only have embedded this via non-automated, non-integrated decision-making loops, reducing again the responsiveness and the flexibility. Finally, what we see is that global competition and increased customer influence typically require close containment of costs and ensuring markets are reached on time in full to protect the revenues by preventing sales to take place at markdown prices. So let's see how these aspects might affect supply chain operations. Goods arriving at the right time, the right quantity, the right place, the right cost. Well, it sounds easy, but often it proves difficult to meet the on-time in full promise in an efficient manner. In addressing the issues deriving from today's increasingly dynamic global markets, companies usually have to find answers to similar areas of concern. Non-automated planning and replanning typically allows freedom for personal interpretation and preferences. It introduces possibilities to deviate from company rules and calculated optimums. In the long run, usually this results in a reduced score on service levels. Reactive transport mode and carrier selection may lead to deviation from pre-agreed and procured carrier allocations. And although at first sight addressing the need on hand, it might negatively impact overall objectives such as reaching minimum thresholds for volume incentive schemes, etc. And forecasting and demand planning have always been an art in themselves, of course. However, knowing what, when, and where to deliver has become even more difficult in today's global markets. Even if forecasting and demand planning are mastered, then a flexible and agile network execution is crucial to comply with things like requests for changes in order quantities, delivery dates, delivery locations, and also the need for increased delivery performance at destination. And finally, the required fast resolution to any supply chain disruptions that might appear. Other concerns may result from a non-integral approach to the end-to-end supply chain network. So using multiple visibility platforms across the network and planning within silos of regions or brands, departments, 3PLs, or product lines, it usually results in suboptimal planning results. Needless to say that the containment of inventory and tight cost control are today obviously important prerequisites for success. So let's have a look how these concerns may be addressed. One typical way to address the challenges of a dynamic world is to rely on the expertise and flexibility of consolidators at origin. And many consolidators actually do a pretty good job. Many execute to their customers' instructions and efficiently organize and load containers. Once the consignments are known, many consolidators are able to optimize the usage of space in a container through a manual or even a software-aided approach. However, especially in a complex, time-pressured and large volume operation, where customers need a high on-time in full delivery performance, then not all consolidators can select the correct equipment type from multiple carriers within a customer's volume allocation restrictions. And depending on complexity, not all can efficiently take into account all the business rules. There's few that will automatically consider that some shipments might actually not have to ship out straight away to still arrive on time at their final destination. Hence, they might be missing out on cost savings potential when combining shipments on hand with any future shipments that come available. And once decided that shipments have to sail on the next available vessel, Few consolidators can take into account that some shipments take priority over others, or that particular consignments might not be combined together into the same container. And few have the flexibility to efficiently replan any moment that the changes occur in things like order quantities, delivery dates, and shipment destinations. Consolidators who can provide this, they may only use little automation, and varying degrees of manual processing time may be involved. Typically it's time consuming, and it increases the risk of making non-optimal decisions. And this is where then really automated load planning may start to yield benefits. So let's have a look at the principle behind automated load planning, and essentially it's the same as a GPS navigation device. It provides a simple tool to use, a tool that helps selecting the best way to move. Typically a GPS would enable you to predefine your preferences, whether you would like to select the fastest route, the shortest route, or maybe even the most scenic route. It will provide you with an estimated time to your destination based on your current speed, as well as the up-to-date information about things like traffic jams. And if you have a good one, it will actually also suggest you to pick a less crowded route. Now that's similar for automated load planning. It will provide you with an optimal shipment plan based on criteria such as delivery time, cost, carbon, transport modes, and carrier. And more importantly, it will optimize your route to market when there are any changes that appear on the demand or the supply side. So automated load planning enables the automated order and shipment planning and the optimization at origin, facilitates the efficient and effective decision making in complex volatile environments. It reduces the time required for planning and optimizing. It ensures adherence to customer business rules, and it optimizes cost and delivery performance while providing insights into the carbon effects, for instance, of the decisions that are made. However, very important for automated load planning to function well is to be certain that the shipments that are being planned, that they're actually available at the origin consolidation points, because otherwise we would end up with an optimal plan, non-existing reality. And for many of our customers, we today start planning only for those shipments that actually have been received at our CFS. However, those customers that have a vendor compliance program in place, they may derive benefits by driving the behavior of their suppliers in such a way that it allows us to start the planning already earlier in the process based upon the receipt of the bookings from the vendor rather than the actual receipt of the cargo. So we're able to reduce the origin processing time and thus also the total lead time. And of course that reduces things like inventory cost. And because we know further in advance what's going to happen, it will also increase the efficiency of the physical operation at the container freight station by just making sure we have people available when they're needed. Now, vendor compliance programs can be set up in many ways, so to drive the desired vendor behavior. And we got two examples that we'd like to share with you. This example here is an example of a large US retailer. It's a customer who faced the issue of their vendors actually delivering cargo too late. And if you look at the graph on the right-hand side, it shows over a number of weeks the numbers of deliveries that came in too late at the CFS. So initially they had this hovering at around the 50 shipments arriving late every week. And when they communicated to the vendors that they would be introducing this compliance program, we saw an immediate effect because those vendors were anticipating what was going to happen. And when the compliance program was implemented, it included things like, for instance, a late booking fee or a late delivery fee, we saw a further decrease in the number of shipments arriving late. So by applying a transparent measurement and a penalty reward system, and by working closely together with the vendors, we've been able to significantly reduce the issue. And so it's funny that even just the announcement of the program has helped to reduce the issue. We have to realize, of course, that no program will be able to completely solve the issue, but it will for sure help. And this is another example. It's an example of a large European department store chain who were actually facing the opposite problem. Vendors weren't delivering too late, they were actually delivering too early, leading to an increased storage cost at origin and early payments due to the vendor due to the fact that they were using Incoterms that said that vendors were to be paid at the moment that goods would be received at the CFS at origin. So the slide is a little bit complicated, but if you look at the two red bars, that indicates a number of shipments that have been delivered right on time. And if we move to the right, every step we move to the right, that's 1 day late. So we got +1, +2, +3, +4 days. And equally to the left, we see -1, -2, -3, -4. And the darker the color, the more shipments were delivered during the 2008 and 2009 period too early. So that had an immediate cash effect on our customer. Now, when we introduced the VCP program, we saw a dramatic effect. From 2010 onwards, we see that actually nearly all of the shipments are delivered to the CFS on time or latest 1 day late. Of course, there's always exceptions, but it has helped us to actually use the vendor booking to do automated load planning rather than only using the information coming available when the shipment actually arrived at the CFS. So let's have a look at the actual automated load planning and how that works. So imagine a typical supply chain environment where your demand and supply of products is volatile, and whilst the products actually follow a static pre-planned sequence of events from the moment they have departed from origin. That means that the decision of what and how to ship at origin often is critical, and it often also is complex. So automated load planning aims to facilitate this complexity and to reduce the time required for planning and optimizing, and also to increase the adherence to the business rules. So it takes into account service levels and objectives as set by the customer. So those will be things like everything has to be arriving on time, obviously, but also which shipments, for instance, can be moved together in one box and which cannot. There's operational restrictions like cutoff times for vessels, and there is what automated load planning would consider as changing circumstances. So even though the rules and the objectives remain the same, things might change in terms of rates, sailings, available capacity, etc. So what it does, it actually makes decisions at the origin, and it makes decisions like, shall we call it from the vendor or not? Shall we hold the shipment, or shall we ship it off? Shall we consolidate or not? What mode, carrier, and departure date to be using? And how can we apply the carrier contract? What equipment to use? And how can we optimize the fill rates? Those are typical questions that are going to be answered by the automated load planning at origin. And the planning typically optimizes overnight. It looks at the available cargo and decides on the best way to ship. And it respects the on-time and full delivery at all times, the business rules of the customers, changing network circumstances, and any operational restrictions. So currently, automated load planning systems often look at decision-making for shipments that are ready to move from the origin. However, if we look a little bit into the future, we may well imagine that more developed systems will be able to change the plans of shipments that have already left. And here is how such system could be expanded. If you look at the dot on the left-hand side, the red dot, you can imagine that, for instance, be a point in the chain where we can still make a decision on the movement. So let's imagine a sea air shipment that has left from Asia and is moving via Dubai, and let's say it's predetermined to go to Paris. Then, of course, what we can do is decide, whilst it's on the move, to see if we can divert that shipment to Madrid. Today, that's often a manual decision involving a lot of paper processing, but we might imagine that in future we have a system that can help us. A similar example would be the dot on the right-hand side, where you can imagine that to be the port of discharge, and then the final mile from the port of discharge to the destination warehouse being planned on barge, but then we find out that that is actually going to be too late. So today a manual intervention could be, for instance, a decision done to move it by a truck. And of course, again, we could imagine that that is something that an automated load planning system could take over and automatically trigger those decisions. So next to steering shipments that are already in transit, we may also use things like the big data capabilities to include the status of shipments that are on the move. and we can include those statuses into our decision making for shipments still at origin. So for instance, we may decide to opt for a faster route to market for a shipment that is still at origin if another shipment containing that same SKU gets delayed in transit. Hence, we may expand the planning parameters at SKU level instead of just shipment level. We can also imagine taking into account other decision factors, such as carbon emissions, once they become even more important than they are today. But let's go back what is available today. And let's explore what may typically happen inside this green box called automated load planning. So automated load planning basically needs to cover three things. As a first step, it shall decide if available shipments need to move at all, and if so, at what speed. So using the required delivery dates and the available shipping options, automated load planning can take all available shipping orders and decide whether to move or to hold each shipment. It can also trigger exception approval loops in the case the shipments cannot be planned within the preset boundaries. And what we see here in this step is that often there is decision tree logic used. And we'll come back to decision tree logic. As a second step, after the decision is made that the shipment shall move, the shipment shall be allocated to the available equipment and the optimum mix of shipments per container shall be found. So within the restrictions set by the customer, such a system can determine if shipments can be combined or not. And next, it shall also select the routing, the carrier, and the sailings based on the customer-specific service target levels and the available shipping options of the equipment. And it will then obviously fit the best shipments into containers, often using a space optimizer algorithm. The final step then is to trigger the actual execution. So once the optimization is done, it may book shipments directly with carriers, if you're talking about the more advanced system, and it can pre-advise the destinations. It may also provide the detailed load plans to the origin so that they know what to be loading into what container. And of course, it can trigger off any of the monitoring processes so that operators can follow what's happening. Operating this way, the costs typically are minimized by optimizing the number of equipment used and also optimizing the space inside containers. So let's do a little bit of a deep dive then on decision trees, because using decision trees as a key component has many advantages. Amongst others, it ensures a strict compliance with your business rules and your prioritization logic. So you need to choose how to ship. And during the implementation phase of any such decision trees, it will actually help you to really rethink if all such rules are necessary. And obviously, the more restrictions that need to be factored in, the less optimal the planning result will be. And what we have seen in working with our customers is that they really appreciate the structured health check that we apply when we look at how they are currently running and planning their supply chains. It helps them to second guess and say, okay, do we really need these rules? One of the obvious handicaps in a more complex environment is that it may be difficult to think in advance of all the various scenarios that need to be included in the decision trees. And you might actually still end up with a large non-defined category of shipments. However, a clear benefit is that in case you want to change anything in the way that shipments get decided on, you can easily change it at the rules of the system and have it instantly applied across your business. So you won't be depending on manual implementation and people reading instructions, etc. It helps in flexibly responding to any required changes. Moreover, you are not restricted to just having one decision tree. You might have multiple ones active next to each other. This may be an advantage when different products or different business units have different needs or requirements, maybe even depending on geographical region or the time of the year. So you might in essence segment your one-size-fits-all supply chain into a custom-made supply chain for every need. In a way, what you do is you're expanding to multiple decision trees depending on multiple factors. So where it may make sense to drive specific shipment behavior and decision-making for specific parts of your business, it typically does increase the planning complexity when applying such. So worse if you ship a large number of shipments and then you need to make decisions in a fast mode. This is typical situations where automated load planning systems may be just a solution that you need to both control and execute the desired complexity. And one of our US customers referred to this as, let's operate the complexity we need. But let us take a look at a future scenario when automated load planning may need to evolve beyond simply just using decision trees. In shipping decisions, what we see is that most of our customers need to balance mutually excluding objectives. So they, for instance, need to balance the on-time in full performance with keeping the cost down, and these typically don't go hand in hand. So when choosing the most cost-effective shipping method, this typically results in slow-moving after consolidated modes of transport, and this may negatively impact the on-time in full performance. On the other hand, if one would strive for maximum on-time in full performance, one would need to ship everything as fast as possible as to maximize the chance of arriving on time. That means things like using a lot of air freight, and that obviously drives up the cost and reduces the cost performance. So in reality, what we'll see is that the optimal choice likely is somewhere in the middle. But depending on which day it is, today's choice might be different from tomorrow's. Decision trees typically won't be able to cope with such dynamics very well, let alone if the optimal service level performance shall be reached over time, rather than for each individual shipment. And maybe when looking over a period of time, we shall decide on shipment to arrive late, hence reducing on-time in full performance, but increasing the cost performance because we want to maximize the consolidation potential with future shipments. This is when things like scenario planning, learning algorithms come into play. And of course it gets worse if we start to add additional optimization objectives, such as carbon emissions. And there's not many automatic planning systems that today can deal with this complexity, let alone a human being in a high volume, time pressured environment. Okay, but let's summarize what automated load planning systems can actually achieve today. So those systems may help companies change their static operations, adapt to new dynamic environments. By applying your business rules and operational restrictions in a decision tree, those systems can quickly determine for all available cargo if a shipment shall be moved or not, and which cargo may be required to combine into the same container. It typically takes into account all the available cargo, required delivery dates, sailing schedules, booking slots, carrier allocations and costs. And of course, decision tree logic often can be changed easily if your situation requires. Automated load planning system can also operate mode independence. So we have been talking a lot about ocean freight, but for instance, if the scope of transport does include air freight, it will typically avoid air freight as much as possible because it will drive up the cost. But it will allocate shipments to air freight in case required for on-time delivery performance. And of course, the way to optimize the space utilization in a air freight container is not really a lot different from optimizing space in an ocean containers. Just a few extra factors that we need to take into account here. And once the decision is made to ship, a container fill optimizer will select the equipment type, plan the optimal stuffing pattern for each container, and the result is a detailed load plan for each container leaving a consolidation center. And depending on the level of sophistication of a system, it may then also include the additional features such as automated approval loops, which will allow you to remain in ultimate control and make the final decisions when the degrees of freedom get outside the preset boundaries. So automated load planning may help achieve maximized fill rates at the lowest cost whilst respecting your delivery promises. It naturally operates automated, avoids human errors, and then it also increases the speed of decision making, whereas it obviously always respects your business rules. Now, before closing off by sharing some of the characteristics of a typical business environment in which automated load planning mechanisms may render value, let's quickly look at a case study from one of our existing customers from the lifestyle vertical. So this global sportswear company, they exemplify the typical environment in which automated load planning renders most value to supply chain optimization. It's a company that is characterized by quite a complex supply chain. They got multiple factories, multiple markets across the globe, and multiple transport modes. And they also have quite a complex set of decision rules. So things like what can we ship, how, when, and under which circumstances. They have strict rules for allocating shipments across carriers. They see constantly changing shipping rates, capacities, availability. They have a large quantity of orders, frequent order changes, and they have limited time in decision-making and processing at origin. In fact, working closely together with their vendors, in some cases we have been able to reduce the origin processing time to around 24 hours, which is quite fast. That is 24 hours between leaving from the dock and being on board the vessel. So by applying a combination of such a vendor compliance program and also automated load planning, the company is able to act much more agile and flexible, and can respond and adapt much more dynamically to changes in the environment they operate in, while remaining still 100% in control of their segmented supply chains. And if we look at the bottom line level, it has been able to achieve a 6% reduction in supply chain costs from the categories that I mentioned here. And they've also benefited from an additional 1% margin increase due to their products hitting their markets faster and more accurately, and therefore not having to mark down products as often as before. So would your company benefit from such an approach? Well, the list shown here provides an overview of the characteristics of a typical business environment in which vendor compliance program and in particular automated load planning mechanisms may render value. What is critically important is a partnership mindset, because of course you can try to automate rules, you can try to force things upon a vendor, but if you don't also look at things from their perspective, things typically don't work out well. So working together closely with both your 3PL and your vendors is important. And it's also important to realize that many of the benefits typically lay outside the out-of-pocket logistics costs. So they will be in things like reduced inventory at the destination because your freight will be hitting dock more accurately. So you need to look at an end-to-end optimization. And of course it works well if you prefer an agile pool-based supply chain. Companies that we see, for instance, working in a chemicals environment, they typically are facing a production situation where products just have to be pushed out purely by the nature of their production. So they would be less likely candidates to benefit. And of course, because automation comes with an investment for things to set up and for things to be maintained, it typically renders value if you have a large number of shipments and you have multiple routes to market. In essence, if the situation is quite complex. It also helps if you have to accommodate frequent changes in either orders or things like rates and sailings. If you've got multiple shipping options from origins, and if you've got many vendors that are shipping from the same origin but have relatively small size shipments, so you're often faced with a situation that you need to choose which shipments go into what container, because obviously if they're all shipping full container loads directly from their factories, there's not much to optimize other than carrier allocations. If you do have a large and increasing number of delivery locations or geographies that you're sourcing from, that just increases the complexity of your networks, and therefore it might help if you have some computer aid to help you make decisions. So on that note, we have reached the end of today's presentation. We have highlighted some of the frequently observed market challenges that contribute to today's markets being less stable than before, required supply chain to be much more flexible and agile. We've also seen two examples of customers who have successfully applied vendor compliance program to ensure that on-time availability of shipments as per the booking, which typically is a prerequisite for automated load planning, that is met. We've showed some examples of how automated load planning may be used in the execution of origin management, and we have covered some future thinking on the topic. So for those of you who are disconnecting now, thanks a lot for your attention, and hope you have today at least seen some interesting things to reflect upon. And I can see that we have just a few minutes for those of you having a chance to stay longer for a Q&A session. So let's have a look if there is any interesting questions that have come in through the chat function in the meantime. So Can automated load planning also be valuable to exporters rather than only to companies who import and sell in the destination markets? Well, that's an interesting question, and I think the basic answer is yes, it can. If the automated load planning is configured to take on-time delivery of shipments at destination as a prerequisite to their plan, it may indeed be a valuable solution to any larger company that is responsible to make sure that the things are arriving on time. So if you're an exporter and you need to accommodate frequent changes in orders or shipping options, then it might help you. So typically it would apply if the Incoterms are set as such that you are the one responsible for taking control of the shipments. So we things like CIF, CIP, DAP, or even DDU and DDP terms. So yes, I do think that exporters can also benefit, and it doesn't have to be only the importers. And I do appreciate that today we have mainly seen some examples from importers, but that's because we've mainly based on our existing experience here. So let's see, other questions. You mentioned a different way of optimizing in future. Can you elaborate? Now, that's quite a broad question. I think we can spend quite some time here. I'm not sure if you want to do that given the time that we have left, but if you look at the dynamic nature of the automated planning systems that are available today, that consists of the ability to automatically replan at any given moment in time. It can replan all shipments available at multiple origins across a network whenever there is any changes that are occurring. And more often, however, those companies rerun their planning once overnight. They take into account any changes that have occurred until that moment. If we look into the future, dynamic nature might combine the current ALB system capabilities with much more of a mathematical algorithm. So this algorithm should determine then an optimal trade-off between the conflicting goals. We talked about that. As we have seen, these include things like always being on time, or always being the cheapest, or always being, for instance, environmentally friendliest. So many systems today use a rule-based and iterative decision approach to determine the best option available. In future, however, they might optimize and achieve service level over a period of time by, for instance, remembering some of the decisions in the past and learning from it. So we might see some learning agents there. Maybe also just simulating some of the scenarios of decision-making in future. So what could potentially happen, and then weighing off the pros and cons there. Let's have a look. What potential do automated load planning systems have to save me money? Well, this obviously is a key question to be answered when considering the use of any automated system, and also for vendor management. And it's a question that we receive from our customers very often. At the same time, it's a difficult question to answer in general, as the situation for every company is unique. Also, when companies want to compare the current as-is versus the to-be of a situation where they would be using automated load planning, it's difficult to compare, and it's basically because that typically you have the risk of comparing apple to pear. The companies might be comparing their current static approach to a dynamic one, and the true value of automated load planning comes from better handling a dynamic environment and thus better accommodating change. So companies become more agile, they become more responsive. But yeah, to put a dollar value to it, we would typically be looking at things like excess inventory, more accurate channel positioning, but they also already benefit from taking out processing time at origin, reducing the transit time, reducing time to handle exceptions in a more structured way, and the ability to implement and adapt business rules more easily. And of course, we've seen the example of that we have shown you where the sportswear brand saved up to around about 5% in the supply chain cost and an additional 1% positive revenue impact to reduce markdowns. But it's not a guarantee. and it's something that that we need to have a close look at for each individual company. I think we got time for just one more question. Let's have a look. Would companies in the automotive industry benefit from automated load planning? Well, that's a very interesting question, because I don't think that automotive sector should be ruled out per se, but I would say that they're less likely to benefit directly. The automotive industry is typically characterized by supply chains that aim to ensure a continuous production flow at the manufacturing line at the OEM. And the production quantities and the required parts typically are pre-planned, with only the exact configuration of parts determined on a short pool term basis. So the quantities and shipping frequencies often are steady for longer periods of time. Pickups from vendors are often executed in pre-planned things like milk run operations, or even the vendors are they're kept responsible for both the transport and the inventory until the products are really available at the factory site or even next to the factory line. So I think that although it's a complex environment, it would likely more benefit from the periodical static network optimization, contrary to more of the dynamic type of optimization that we would see when we would be applying automated load planning. I think with that,